Hello, geometry folks. Today we're going to be talking about the converse of the Pythagorean theorem. Remember, converse means the theorem backwards or in reverse order. So what we're going to need today is your notes, the foldable that I gave you in class, a pen or pencil, and of course a calculator. So the Pythagorean theorem says if I have a right triangle, then I can use the equation a squared plus b squared is equal to c squared. But the reverse of that now is saying if we find out the relationship of three sides of a triangle, a squared plus b squared is equal to c squared, then I must be a right triangle. So thinking in reverse, we're going to use that equation to determine if the triangle is right. So we're going to be talking today about what kind of triangle am I? Acute, obtuse, and right. All right, so what makes a right triangle? Well, obviously, the first thing we always look for is a right angle. But in our image below, the blue triangle, we don't have a right angle, even though it looks like it. We want to say that this is a right angle, but we don't know for sure. That image didn't give us that little box to tell us. So if we don't have that, how do we know if we have a right angle? We're going to have to use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And then we're going to plug in the three side lengths that our blue triangle gave us to see if both sides of the equation equal each other. So the c value is always going to be the longest leg. So 20 is going to be c, and it doesn't matter if 12 is a or 16 is a. So I'm just going to say 12 is a and 16 is b. So what we have to do now is plug these three values into the equation or the Pythagorean theorem to check to see if the two sides equal each other. So a squared would be 12 squared plus b squared is 16 squared equal to 20 squared. 12 squared is 144 plus 16 squared is 256, and that is equal to 20 squared, which is 400. So our question now is 144 plus 256 equal to 400? And as we know, it is, so 400 does equal 400. This is a true statement. So when this happens, that means that we have a right triangle. So we can draw in that box because we know for sure because we checked with the Pythagorean theorem. What happens if it isn't a right triangle? What if our statement wasn't 400 equal to 400? What if it was 300 equals 400, which isn't true, or something to that extent? If that happens, we're saying it will be obtuse if the hypotenuse number, which is that c value, which is across the largest side, that hypotenuse number, or the largest side, that c value, if that's bigger or too big than the a squared plus b squared, you're going to get an obtuse triangle. If the hypotenuse number, or the largest side, is too small, then you're going to have an acute triangle. So the Pythagorean theorem can still tell us what kind of triangle we have, even if we don't have what we did in the last one, like 400 is equal to 400. So make sure that you fill this in your little foldable. I think you have some words to write in. So with that, we'll look at some examples. Okay, so let's look at the first example. We need to classify the triangle when its side lengths are 8, 18, and 24. When they say classify, they're asking us to say, is it obtuse, acute, or right? What kind of triangle is it according to its sides? So we're going to use the Pythagorean theorem, a squared plus b squared is equal to c squared, with c, our largest value, being 24. So we're going to plug in our values. So a squared plus 18 squared is equal to 24 squared. 8 squared is 64 plus 18 squared is 324 equal to 24 squared, which is 576. So now we need to add 64 and 324, and by the looks of it right now, it doesn't really look like we're going to get to 576, and when we add them together, we get 388, which is not equal to 576. So remember, we said that the 576 number is my c value, or my hypotenuse, my hippo. So this number is bigger than 388. It's too big. So if we look back in our little foldable, when we have something that's too big and it's not equal to, it's not a right triangle, this triangle is going to be obtuse. Okay, just like the last one, we're classifying the triangle when its sides lengths are 12.3, 16.4, and 20.5. So we're still using the Pythagorean theorem, a squared plus b squared is equal to c squared, with our c value being 20.5 because that's our largest side or our potential hypotenuse if this is a right triangle. So you'll probably need your calculators for this one since we have decimals, so it's going to be a little trickier to square them. So we have 12.3 squared plus 16.4 squared all equal to 20.5 squared. 12.3 squared is 151.29 plus 16.4 squared is 268.96. And then that is maybe equal to, we're going to see, is that equal to 20.5 squared, which is 420.25. Okay, so we have 151.29 plus 268.96. Is that equal to 420.25? Well, these two numbers added together give me 438.25. which is not equal to 420.25. So, is this number bigger or smaller than the left-hand number? It's too small. It's not equal to 438, excuse me. It's smaller than that. So since this number is too small, we will have an acute triangle. All right, and our last example today in our foldable is classifying the triangle when the sides are 4, 4√3, and 8. Remember, our largest value is going to represent our C value. In case we've forgotten, which I highly doubt we have in this lesson, is the Pythagorean theorem, a squared plus b squared equals c squared. So we're going to square each of these lengths. 4 squared plus, and I'm going to put in parentheses 4√3 squared equal to 8 squared. Well, we know 4 squared is 16, and we know 8 squared is 64, but we're going to have to remember how to square 4√3. Remember, this 4 times the square root of 3 is a product. It's being multiplied. And whenever we take a power to a product, each factor of the product has to be raised to that same power. So what I'm saying is we're taking 4 squared times the square root of 3 squared. So 4 squared is 16, and the square root of 3 squared is the same thing as, and this is a side, the square root of 3 times the square root of 3. That's the same thing as 3 squared, and we know the square root of 3 times the square root of 3 is just 3. So I'm saying that we have 16 plus 16 times 3 all equal to 64. Well, 16 times 3 is 48, and then we just bring everything else down. So this is a little bit of review of order of operations, or PEMDAS. And now we're taking 16 plus 48, which is 64, and that is indeed equal to 64, which means we have what kind of a triangle on this one? We have a right triangle because the two sides of our equation on the Pythagorean theorem equal each other. 64 is equal to 64. And that's all I have for you guys, so I want to thank you for taking good notes, and I will see you soon.